So as of now, we know that what is the meaning of parallel connection in any of the circuit, like we have seen for voltmeter, just for an example. So we are doing parallel combination of resistors. Resistor is a device which measure resistance. Okay, it's different. So how does a parallel combination looks like? So there will be a circuit in which there will be, once again, I'll be taking 3 resistors. We can take as many resistances as we want. Okay, as many resistors as we want. So this is a circuit in which we have same battery. There will be a switch and it's closed. Battery will supply V volt and the current in the battery, the current in the circuit will be I. Current comes here and now we know that current will actually divide at this junction that we have seen earlier also. So let's say I1 goes in the first branch, I2 goes in the second branch, while I3 goes in the third branch. Okay, so the first conclusive point over here is that current is getting divided. It is just opposite to that of series. Okay, over there voltage was getting divided. So current divides in parallel combination. If I talk about voltage, so voltage across, if you look at the initial and end point of each of the wire, each of the branch where R1, R2, R3 are connected, so they have a same initial and end points. Let me name them as number 1 and number 2. Number 1 and number 2 is just an indicative number. I just want to show you that all 3 resistances are connected with 1 and 2 only, in between 1 and 2 only. So I can say that voltage across each one of them will be same. Over there it was different. Okay, just try to connect this thing with the series combination. It will be easy to understand. So over here voltage is same but current divides. We have the same formula, V is equal to IR, but this time we are talking about like current divides, so current will be same. So I can say that current is equal to V by R, and if I want to write the value of I1, then I will write I1 is equal to V over R1. The value of I2 will be V over R2, while the value of I3 will be V over R3. Okay, I1, I2, I3 are the respective currents for different wires, for different branches, as you can see in the diagram. Now the net current in the circuit, as we can see over here, that the net current was I and it is getting divided into I1, I2, I3. So I can say that net current I will be equal to I1 plus I2 plus I3. Over there we were talking about voltage. Okay, so if I just put the values of I on both the sides, then this I, which I am putting it in box, this is a net current which is flowing across the whole circuit, whose potential difference is V, and the net combination of resistances for these 3 will be R. So we are trying to find this R only. So we'll write V over R as a replacement of current on the left. Then I1, I2, I3 values are there. We'll just plug all the values and I'll get V over R1 plus V over R2 plus V over R3. Now in this it is clearly visible that V is same on all 3 of, like for both the sides. So if I divide both the sides by V, I will be left with 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and it can go on for as many resistors we are applying. So this R is the equivalent resistor required to get same value of resistance for the circuit. Okay, what is the meaning of this? These 3 were giving some value of resistance for the circuit. Okay, so if I want an effective resistor which can replace all 3 of them, then I can replace it by a single R, and that R will be obtained by this mathematical relation. We'll definitely do a question to make this thing more clear, but this is how the mathematical relation will work for parallel combination of resistors.